Find the volume under the surface z equals to x squared plus y squared over the disk, x squared plus y squared less or equals to a squared. Well, if you say x squared plus y squared equals to a squared, that's a circle of radius a, right? And if you say less or equals to, that's like the interior of this disk. Find the volume under the surface z equals to x squared plus y squared over this disk. So what you're trying to do is you have this double integral over this disk, and you're integrating this function. That gives you the volume under the graph of a multivariable function, right? So you could do this using rectangular by solving this for y squared first, and then solve for y as plus or minus square root of a squared minus x squared. So in that case, you would be painting this region starting from the minus. This is minus square root of a squared minus x squared. The top is positive a squared minus x squared. So you can start from here and there. So if you were to use rectangular, you would write minus square root of a squared minus x squared, and you end at a squared minus x squared with x value varying from negative a to a, and x squared plus y squared dy dx. You can certainly do it that way, but you'll quickly see that if you do it this way, it becomes really hard to compute. And that's where the polar integration comes in. So when your region is something of a circle, then often it's better to just use the polar integration. Okay, so how do you do this in polar? You first say that the equation for a radius a circle is just simply r equals to a. Now that's kind of obvious. If you have r equals to a, that's like you're plotting only the points which is distance a away from the center, so you end up with the circle of radius a. Or another way to get this result is to simply say r squared is equal to x squared plus y squared. So this equation in polar will be r squared equal to a squared. So if you solve it, you get r equals to a and r equals to negative a. And they both give you circle of radius a. And you just need this, okay? Alright, so we know that the outside circle is r equals to a. And therefore, first x squared plus y squared, that's r squared. dA is r dr d theta. Please don't forget this r. Okay. And then your r value, since dr is inside, you try to paint this circle radially. So how do you paint this radially? Well, you start from 0 always, radially starting from the origin. You start from 0 and you end at when you reach this r equals to a, right? So r value starts from 0 until a. On the other hand, because you have the entire circle, theta goes from 0 to 2 pi. Okay, now we are ready to compute this. What is that? R squared times r, that's r cubed, dr d theta, 0 to a, 0 to 2 pi. Integrating r cubed gives you 1/4 r to the 4th, a and 0. And then you still have to integrate by theta from 0 to 2 pi. That just gives you a to the 4th over 4. But because this is a constant, when you integrate by theta, you end up with just theta, and then you plug in 2 pi and 0. So at the end, this gives you the answer as a to the 4th over 4 times 2 pi, and 2 cancels, so it's pi a to the 4th over 2. That's the answer.